Hey everyone, welcome. If you're getting ready for that big electrical exam, or maybe you just want to make sure your skills on the job are, rock solid, then you are in the right place. We're going to dive into a quick guide to mastering the absolute fundamentals of electrical wiring. This is the stuff that can mean the difference between passing and failing, and way more importantly, between a safe job site and a really dangerous one.
So let's just get right to it. What are the top things that cause people to fail their exams or create hazards out in the field? What are those simple mistakes that consistently trip people up, both on the test and on the job? If you know what they are, well, that's the first step to making sure you don't make them. And check this out. This quote really hits the nail on the head. We're not talking about some super complex electrical theory here. Nope. Instructors say again and again that the biggest mistakes are in the basics. Things like misreading a wiring diagram or messing up the color codes. But hey, the good news is these are so avoidable once you just learn the rules. Okay, so here's our game plan. First, we'll talk about why this basic stuff matters so much. Then, we're going to decode conductors and their colors. After that, we'll get into making a really secure connection. Then, we'll learn how to read those wiring blueprints like a pro. And we'll wrap it all up with your 5 essential rules for success. Sound good? All right, let's jump into part 1, decoding conductors and colors. Everything in an electrical system, it all starts with the wire. It's the foundation. If you pick the wrong wire or you don't understand what its color means, the whole system is basically broken from the start. So let's make sure that never happens. Okay, before we even get to the colors, we gotta talk about wire size. There is one, and I mean one, super important rule about sizing that you just have to know. And honestly, it's a little backwards, which is probably why it trips so many people up on their exams. And here is the big rule. With the American wire gauge system, you'll see it as AWG. The smaller the number, the bigger the wire. Seriously, say it out loud. Smaller number, bigger wire. So a 12-gauge wire is actually thicker and can handle more juice than an 18-gauge wire. You have got to lock this into your brain. And look at this. It really shows you what we're talking about. This isn't just some abstract rule, right? A thicker wire, a smaller AWG number, just has more copper in it. That means less resistance, and less resistance means it can safely carry more current. That's its ampacity without getting hot. And trust me, using a wire that's too small for the job is a huge, huge fire hazard. Okay, so now that we've got size down, let's talk color codes. And listen, these are not suggestions. They're a non-negotiable language of safety. Your hot wires, usually black or red, they're the ones carrying the voltage from the source. Your neutral, which is going to be white or gray, that's the return path for the current. But the big one, the one you can never, ever mess up, is green or bare copper. That is for equipment grounding, for safety only. It should have 0 current on it unless something has gone wrong. Mix up neutral and ground, that's an automatic fail on your exam, and it's a super dangerous situation on a job site. So you've picked the right size wire. You know the color code. Awesome. But guess what? That perfect wire is totally useless if it's not connected securely and safely. And that brings us right to our next part, making a secure connection. It all boils down to 3 simple things. First, you gotta strip the right amount of insulation off the end. Too much is bad, too little is bad. Second, you have to make sure every single little strand of that copper wire gets inside the terminal. No stray whiskers. And third, and this is crucial, you tighten it to the proper torque. If you nail these 3 steps, you'll prevent all that dangerous heat and arcing that cause big problems. And here's exactly why that last step, the torque, is so critical. Think about it. A loose connection creates resistance. And when electrical current tries to push through resistance, what does it do? It generates heat, a lot of heat. So this is not about just cranking it down until it feels tight. No way. It's about using a proper torque wrench to hit a very specific number from the manufacturer. It's not just good practice, folks. It's literally fire prevention. Now, making a good connection also means protecting it from the world around it, and that's where NEMA enclosures come into play. Just think of it like a matching game. Got a clean, dry indoor room? A NEMA 1 enclosure is probably all you need. But what if you're outdoors or in a factory that gets hosed down? Well, then you better be using a NEMA 4 for that water protection. Getting this wrong is a big deal. Sure, using a NEMA 4 when you only need a 1 is a waste of cash, but the other way around, putting a NEMA 1 box in a wet area, that's a recipe for equipment failure and a serious safety hazard, so you gotta be precise. Okay, so we have the right wire, we have a secure, protected connection. Now for the big question, where does everything go? Well, that brings us to the next essential skill,
reading the wiring blueprint.
All right, here's the thing you have to understand. You're usually going to be working with two different kinds of diagrams. First is the schematic. The schematic shows you the logic of the circuit. Think of it as what connects to what. Then you have the physical layout diagram. This one shows the location, as in where the wire actually runs and where the parts are physically located. You have to use them together to get the full picture.
And as you're looking at these diagrams, you're hunting for three key pieces of information. First, the wire numbers. Every wire gets a unique ID, so you can trace it from one end to the other. Second, the terminal designations. You'll see something like TB11. That tells you the exact screw you need to connect to. And of course, the color conventions we already talked about. Accuracy here is everything. I'm not kidding. Putting just one wire on the wrong terminal can make the whole system fail, or worse.
All right, we have covered a ton of ground, so let's bring it all together. In this final part, your rules for success. Think of this as your ultimate cheat sheet. These are the absolute, non-negotiable rules that will make sure your work is safe, professional, and gets you that passing grade on the exam.
I mean, look at that. This is what you're aiming for. Clean, neat, organized, and perfectly correct wiring. It's not just about making it look pretty, although that's nice. It's about creating a system you can trust to work safely and reliably, every single time. So let's do a quick-fire recap of the rules that get you to this level. Okay, let's nail this down. Rule 1, AWG, smaller number, bigger wire. Got it? Rule 2, colors. Green is only for ground. White or gray is neutral, black or red is hot. Rule 3, terminations. A loose connection creates heat, so always use a torque wrench. Rule 4, enclosures. Match the NEMA rating to the environment. And Rule 5, diagrams. You have to follow the wire numbers and terminal IDs exactly. No exceptions. Master these 5 points and you are golden.
So I'm going to leave you with this one last question to think about. You know the rules now, right? That's the first half of the battle. The next part is applying them. So, can you look at a wiring diagram, a really complex one, and spot the mistakes before they happen? Can you see the wrong color wire being used? Can you spot an undersized conductor? That's the skill that really separates the pros from the amateurs. Keep practicing that and you'll be unstoppable.